So this is Math 3, Unit 2, Section 3, Solving and Graphing Absolute Value Inequalities. So I am going to have an absolute value that is either less than or equal to, greater than or equal to a value. So you can see that this is kind of split down the middle. Let's take a look at less than and less than or equal to first. So you can see that all of our answers that we're going to get for x, which is called our solution set, is going to be between a positive b value and a negative b value. Okay? Well, let's think about that. If I take the absolute value of a number, and that number is 3, like we did yesterday. Absolute value of a number, and I get something less than 3. What is a number that would work to plug in for x? 2. Awesome. So the absolute value of 2 is going to give us 2, which is less than 3. What's a negative number that would work for x? -1, or even if we stay consistent with our first example, -2, right? So the absolute value of -2 and the absolute value of +2 are going to give me the same answer, and 2 is less than 3 in both cases. So I have a positive version and a negative version. Same thing with 3. I'm going to get an open point if I have no equal to sign, but if I have an equal to sign, I could choose the absolute value of 3 is less than or equal to 3, and the absolute value of -3 is also less than or equal to 3. So that's where we get our positive and negative b from, because anything in between. So +3 would work, +2, +1, 0, -1, -2, -3, and then any numbers in between those that are decimals. So that's why the solution set is in between these values. So whenever you see a less than symbol, I want you to think and. So x is between -b and +b. X is between -b and +b. And the reason for that is if we were to split this, and I would just say, well, let's do this side. X is less than b. Well, that's true because all of these values are less than 3 that I plugged in. So like this 2 and the -2 are less than 3. But if I plug in -4, that's a value less than b that would not work, right? If I took the absolute value of -4, that would not be less than or equal to 3 because I would get a +4. So that's why we have to use the and, is because it has to be less than the positive version and greater than the negative version. Now when we have greater than signs, that's when we're going to think or. So you'll start to hear me ask you, is this an and question or an or question? If it's less than, it's and. If it's greater than, it's or, because we're going to have solutions on the outside of those values instead of between those values. You can always plug in numbers like we did at the top to check if you're unsure. So we have a couple special cases. When my b value is less than 0 and I have the absolute value of b is less than b, that's just saying, hey, when you take the absolute value and it says it's less than a negative number, so like -6, is that possible? Yes or no? Not possible. Why not? Why is that not possible? Because this answer of an absolute value is always going to be positive, and if you have less than a negative number, you'll always have a negative number. So that's going to have no solution. Same thing over here, less than or equal to. If it was an equal to, that would have no solution. Okay. Here's another special case. When b is less than 0 and the solution set for both the absolute value of x is greater than a negative number, so we're going to use -6 again. When is taking an absolute value greater than a negative number? When is taking an absolute value greater than a negative? Well, absolute value is going to give you a positive number, correct? When's a positive greater than a negative? Always, right? A positive is always greater than a negative. So that's going to give you the answer of all real numbers. Questions so far? Okay, so remember we have our steps to solving algebraically, which is for part B. So I'm going to go ahead and highlight the algebraic part so I know where my steps are that I'm using to solve. But before we do that, we're going to start graphing on the left-hand side. So we're going to graph the absolute value of x minus 2. We have x and f of x. What's my vertex here? Good, 0, -2. Would you like to plug in points or would you like to use the slope? Slope, okay. How do we know that we can use slope? Yeah, so it's an absolute value problem, so that makes it a straight line. So I can use the positive slope and the negative slope to go in the other direction. Is this going to open up or down? Up, okay. So my slope is 1. I'm going to go up 1 over 1. And I'm going to go up 1, back 1. And we're going to label that f of x. Okay, same thing that we did in section 2, yes? We graphed them and we were trying to find solutions. So where does g of x, which axis is g of x equals 3 going across? Yeah, which axis? That's okay, yeah. The y-axis at 3. And if I wanted to show plugging points in for g of x, well, we know no matter what, g of x is going to equal 3, so it doesn't really matter what my x values are as long as I get a g of x value of 3. So this is where we're different from section 2. Section 2 asked to find the solutions when f of x equaled g of x. But section 3 says highlight the portion of, this is very important, highlight the portion of g of x, so you're only highlighting on g of x, so you need to know which function g of x is, where f of x is greater than g of x. So when you did when you've done graphing in the past, where is a function greater than another function? When it has a greater x value or when it has a greater y value? Greater y value. It's always talking about the height. So if you need to remember, these two are both talking about height. All right, so we want to know where f of x is greater than g of x, and then we're going to highlight on g of x where that happens. So basically, where is f of x higher than my straight or my constant line, my horizontal line? On the inside or on the outside? On the outside. Now, you're not going to highlight on f of x. We are going to highlight on g of x where f of x is higher than that portion. You will have to highlight on your homework, so make sure that you're either borrowing a highlighter or you have a highlighter. Okay, so we highlighted the portion of g of x right there, where f of x is above basically g of x, and we're going to state the interval. So we want to know the interval along the x-axis for these highlighted portions. So if I start on the left, my domain for the highlighted portion goes from negative infinity to what number? Domain is my x values to negative 5. And then why am I using parentheses here? It is an interval. We are going to end up using brackets at some point, but it's because this one is greater than, it doesn't have an equal to sign, so think of these places as open points. Does that help? Okay, so if we have open points here, then I should be using parentheses, and then I'm going to do a union, and I don't start again until positive 5. And then where do my x values go after that? Infinity. Good. Okay, so there's my, we're still doing a domain interval, so I still want to use parentheses and brackets, but if it says open interval, that's when you don't have to worry about brackets. Okay, now we're going to solve algebraically. So I want to put f of x greater than g of x. Okay, so we want to isolate the absolute value on the left-hand side of the inequality. So we're back up here at our steps for solving algebraically. Is my absolute value isolated? No. What is extra? Minus 2. So how do we get rid of subtraction? Addition. Very good. So plus 2 on each side. We get x is greater than 5. Sorry, the absolute value of x. All right. Now we want to check right here. There are some cases in which our absolute value will be greater than 5, and there are some that our absolute value will not be greater than 5. So I just want to make sure that I don't get any of my special cases right here. So it would be a special case if I was saying the absolute value is greater than a negative or the absolute value is less than a negative. Okay, so just like on the previous section when I got the absolute value equal to a negative, that's when I wanted to stop. and tell me what type of special case it was. So if you ever get a negative on the right-hand side here, please stop and check the special case. But right now it's positive, so I do want to split them into two equations, which is x is greater than 5. And the other one is going to be x is less than negative 5. Do you notice how two things changed there? Okay, we know that the value inside the absolute value has to either be, this x value has to either be a positive 5 to take the absolute value and greater than 5, or a negative 5 inside the absolute value to get our open points. But if you change to a negative, it's just like when we were doing our practice for inequalities. What happens if you multiply by a negative? Very good. It switches the sign. So my two answers here are x is greater than 5 and x is less than negative 5. So I should have analyzed whether this was an and problem or an or problem before I split anything up, okay? So it's greater than, it's a greater than symbol. Does that make it an and problem or an or problem? Up at the top here, greater than means or, which means my solution set is going to be outside. So we have to split it up. So this is an or problem. That's when we split. My number line is going to look like this. Here's my negative 5, and here's my positive 5. So if x is greater than 5, I have an open point on 5, can't be equal to 5. But everything greater is to the right. And then if x is less than negative 5, can't be equal to, so I have an open point, but less than is to the left. And that's what our graph looks like. So you will have to graph on the number line on your homework. Questions so far? All right. Let's graph the next one. Okay, so f of x equals negative 3. That's my constant. Please make sure you're labeling each function. And g of x is my absolute value function, so that's going to be my v. Is my v going to open up or down? Down, very good. It's negative out in front, so it's going to open down. We just want to remember to check that. Where's the vertex of this function? Negative 4, 0. Good, so if I plug in negative 4 plus 4 is 0. A negative 0 is still 0. So I'm going to go left 4, up 0. Would you like to plug in negative 3 and negative 5, or would you like to use the slope? Slope. What is your slope? Negative 1. So we're going to go down 1 over 1. Down 1 over 1. What other direction am I going? Down 1, left 1. Don't forget to label your function. So now we need to do part A, which is highlight the portion of f of x. We're only highlighting on the constant line. Highlight the portion where g of x is greater than or equal to f of x. So, where is g of x above f of x for which x values? On the outside or on the inside? Inside. So inside is where my f of x or my g of x function goes above this horizontal line. Okay? Over here, outside was where my function went above my horizontal line. That's what we're highlighting right now. You need to pay attention to a couple things. You need to make sure you're checking the correct sign. So these were both greater than and greater than or equal to. So that's why we're checking to see where the function is above. But we're always going to highlight on that horizontal line. All right. So, do I want closed points or open points at those values that intersect? Closed, because we know that it can be equal to those values. So we're going to go from the lowest to the highest x value of that highlighted portion to write our interval. What's the lowest x value? -7. And why did I use a bracket? Yeah, because the equal to sign, because it's a closed point. And then my highest number is -1. So those are my x values for the highlighted portion. Now I'm going to set up g of x is greater than or equal to f of x. So I have a negative absolute value of x plus 4 is greater than or equal to -3. Before I can analyze anything, I need to isolate my absolute value. Is it isolated? No. What do I need to get rid of? The negative or the -1. So you can either divide by -1 or multiply by -1. Either way. If I divide by -1 on each side, -1 divided by 1 is, sorry, -1 divided by -1 is +1. -3 divided by -1 is +3. Oh, what happens here? Good. Change the sign because we divided by a negative. Now this is very important. This is where we determine whether this is an AND problem or an OR problem. So let's go back to the top. We have a less than sign. Is that an AND problem or an OR problem? It's an AND problem. So your answer or your solution is going to be between the negative and positive b value. So my b value is 3. So x plus 4 should be between +3 and -3. So I want you to write it like that instead of splitting into two equations. Here's the deal. You can split into two equations and then put it back, but most people forget to put it back. So I want to make sure you know when it's an AND problem. So if it's less than, we want AND, which means our x value is going to be between two other numbers once we solve. Okay, so now how do we solve? We have three different things. So if I look at the right-hand side and I were to solve that, what would I do? I would subtract 4 from each side, right? So in order to isolate x, I would subtract 4 to the right-hand side. Okay, what if I just looked at this part? How would I solve for x? Still subtract 4, but to the left-hand side, right? So what's going to happen here is I am going to subtract 4 from each piece in order to get my answer. that isolates my x value in the middle. Because 4 minus 4 is 0. Alright. When you subtract, does your sign flip? No, only when you multiply or divide by a negative. So, what is 3 minus 4? Negative 1. And what is negative 3 minus 4? Negative 7. So your answer is negative 7 is less than or equal to x, which is less than or equal to negative 1. Let's look at our interval. Do you see how it goes from negative 7 to negative 1? That's what this means. X is between negative 7 and negative 1. So these two things should match each other. Just like up here, on our first example, these match each other. If x is greater than 5, that's this side of my union. If x is less than negative 5, that's this side of my union. So I've represented my information 3 different ways. I've represented it as an interval, I've represented it in inequality notation, and my third way is graphically. I've graphically done it on the left and on the right on just a number line. Questions? So we know that if this was just on a horizontal line, it should look a lot like this, where we're between negative 7 and negative 1. I have closed points, and my highlighted portion is outside or inside? Inside. Good. All right. Go ahead and flip to the other side. Okay, so these ones we don't have to graph. We're just going to do algebraically. My first one is isolated, so the very first thing I need to do is analyze whether it's an AND problem or an OR problem. Matea. Is this, so looking at the other side, so this is a less than. Is it an AND problem or an OR problem? So if it's less than. Yeah, oh yeah. Sorry. Couldn't hear you from the back. Yeah, so it's less than, so it's going to be an AND problem, and all that means is your solution should be on the inside between two numbers. So when I set this up, this should, 3x minus 9 should be between negative 12 and positive 12. That's why we call it a AND problem. It's between negative 12 and positive 12. Let's see. Alright, so in order to solve, I need to do the same thing to each part. So there's 3 different parts. You're used to 2 because you have 2 sides of an equal sign. But I'm still isolating for x, so what do I get rid of first? Good, plus 9 to all sides, or all portions, all pieces. Okay, so negative 12 plus 9 is negative 3.
Just a reminder that Impact is meeting in the library annex right now. If you are on the Impact Committee, please head over to the library annex.
Okay. Now what do I do to isolate x? Divide by 3. And we have to do it to all 3 pieces. So I get negative 1 is less than. Why does my sign not change? Good. Just because you do negative divided by positive doesn't mean you divided by a negative. So then I get 1x, which is just x, and good, 7. So this is between, x is between negative 1 and positive 7. So can it be equal to negative 1? No, so we do an open circle. Can it be equal to 7? No, so we do an open point. I should have said point, sorry. And our shading is in between. Questions? All right. The next one to the right. Is my absolute value isolated? No. So first we want to isolate it. What do we do? Good. Add 1 to each side. Okay. Is this an and problem or an or problem? Or. Greater than is my or problem. Less than is my and problem. Whether it has an equal to or not. All right. If it's or, then that means we're going to have to split it. But let's make sure that we don't have to have any other special cases. The only other special cases are when this b value is a negative number. So we want to check, is that a negative number? No. Is it less than? Okay, we're going to put it in the middle of two numbers. Is it greater than? Then we're going to do our or, which means we split it to 3/4 x is greater than or equal to 6, or 3/4 x is, well, we know we need the negative 6. What type of sign do I do here? Less than or equal to, because if I change from a positive to a negative, then that means the sign changes. Very good. So then I want to solve for x. So you can do two things. You can take care of your division and then your multiplication, or you can multiply by what? What do we do to get rid of a fraction? What do we multiply by? It's reciprocal. So you could just multiply by 4 on each side and then divide by 3. Or you can multiply by the reciprocal, which would do all of that at once. Multiply by 4, divide by 3 on each side. This side cancels, right? Because I get 12 over 12, which is 1. And 1x is just x. On the right-hand side, 6 times 4 is 24. What's 24 divided by 3? 8. So you would get 24 over 3, which equals 8. On the right-hand side, we're still going to do the same thing. Multiply by the reciprocal. And we should get a similar answer. But now we get 24 over, negative 24 over 3, which gives me what? Negative 8. All right. Here's negative 8. Here's positive 8. Can my answer be equal to 8?
Yes.
Yes. So I'm doing a closed point there. And then we want greater than. Which direction do I go? To the right. Over here, can it be equal to negative 8? Yes. And X is less than negative 8, so I go to the left. Okay, one more example together. We're going to do this next one. Is my absolute value isolated? No. So how do I get rid of a fraction? Multiply by the reciprocal. How do I, what's the reciprocal of negative 2 over 3? Negative 3 over 2. Make sure it's the negative, because you want to do a negative times negative is positive on the left-hand side. What happens when you multiply by a negative? You change the sign. And then we get 6 times negative 3 is negative 18. 1 times 2 is 2. What's negative 18 over 2 equal? Negative 9. All right. This is one of those special cases, right? I said when your B value, which is the number on the right-hand side after you've isolated your absolute value, if that is a negative number, it's a special case. So let's think about it. Which special case is it? Can an absolute value ever be ever be less than a negative number? No, never. So this is false, which makes my answer no solution. Let's talk about if my sign was the other way around. So here's the deal. You're going to get the wrong answer if you forget to flip your sign, right? So if you didn't flip your sign and got greater than, when you went to analyze your special case, you would have said the absolute value is greater than a negative number. That's true, right? That's always true. So if you get greater than a negative, then that means you're going to have the answer of all real numbers. Okay? Any questions?